Good afternoon, everyone. Thanks for coming along. It's impressive to see a packed room considering the quality of some of the other sessions on, but thanks for coming along. My name's Reto Meier. I'm a developer advocate for Android. This is Michael Mahemoff. He's a developer advocate on the Chrome team.
Hey.
Today, we're going to have a bit of a lighthearted debate looking at some of the comparative differences or advantages of developing for mobile using either native libraries or web tools. So before we get started, it'd be good for us to have an idea of the audience, see where we stand, see which of us needs to be more convincing. So with a show of hands, how many of you are doing web-based mobile development? Ooh, I could be in trouble here.
Pretty good. In the Android track, nice.
And how many of you are Android developers? Outstanding.
I think you're on safe ground here.
Yeah, I like this. I like this. All right, so we're both going to have to be really convincing. That works. That works pretty well. So to get started, I'm going to introduce or let Michael take us off with some mobile tips for web development.
Excellent. So yes, I'm making the case for HTML5. And of course, when I talk about HTML5, I'm not just referring to the actual technical spec. I'm talking about all the cool web technologies we can use today. The open web stack of HTML5, or HTML, CSS, and JavaScript, and just this general trend towards getting more know-how about how we're doing things, about faster browser runtimes, and a whole community that's evolving around these standards. I want to frame this argument around these 3 points. So basically to say that HTML5 is a technology that is here on the various mobile platforms. And then I want to tell you that HTML5 is a very capable technology as well, because I could say that batteries are also available on the various mobile platforms, but they won't write your killer apps. Hopefully, I can show you that HTML5 will. And finally, to talk about some of the openness and the fact that it's such a widespread standard as an advantage even over a single native capability or a single native platform. So in summary, to show you that HTML5 on the mobile devices rocks. Firstly, the HTML5 is here on the various mobiles. And that's a bit of a summary of some of the native platforms you have to consider when you're actually going to reach people on the different mobile devices. Linux systems, Microsoft, Apple, and all these different versions. Each of those things have got their own programming language to deal with. And APIs and SDKs, all of those things differ, and you're going to be having to do a lot of relearning or a lot of outsourcing and a lot of work if you want to actually target all the different users using these various mobile devices. So this is why you get comments like this. This one's from the magazine industry. They've got these sort of monthly or weekly publications coming out and just struggling. It's costing them a lot of time and money to actually have to go through and test, see what the content's like on all these different sort of, all these platforms that they're putting their apps out onto. It starts to become compelling to think about, could we have one platform to target all of these different devices? And HTML5 is here. It's working on the mobiles of today. You couldn't imagine getting a new phone without having a browser, and many of them do have the latest features of HTML5. Many of these phones are using WebKit, which is what we also use on the desktop browsers like Chrome. They're also on the tablets and even on other devices as well, like TVs. So they have browsers. You can put your apps in browsers. Users click on links when they see a tweet, for instance. They'll click on a link, and that's what that will be open is the browser. So you need to be there on the mobile web ready inside people's browsers. And you can also embed your apps or your web apps inside native apps as well. There are techniques for this. On the whole, the various operating systems have said, we don't want the experience of a user having to click when they see a link and then it would open up a separate browser app. So the various native platforms tend to provide a way to actually embed a web view inside a native app. And because of that, web developers have taken advantage of that to actually embed their own web app inside the native app that they've actually published. So when you look at these various programming languages, you can also look at another way. You can say, well, let's just deal with it as one platform, one programming language, one set of APIs, one set of design patterns and conventions. But is this for real? Like, can you really try to pull this off, this idea of one platform and one programming API everywhere? The reason it works is not because of some magic that says that you write the same app everywhere. It's because you do actually have the same technologies everywhere, but you still have to do some customization and make things fit the device you're actually working with. So right at the heart of the web is all of these concepts of dealing with multiple types of devices. The web has these three technologies, HTML, JavaScript, and CSS. You know, that they distinguish the content being the HTML, that's something like a content creator, might be a journalist, that's the thing that they're actually creating. The JavaScript is the logic, that's the thing that programmers create to actually control the user-computer interaction. And the CSS is the kind of thing designers work on. And so because you get that separation, you can reuse a lot across the different devices. You can have almost the same or exactly the same HTML, the actual content. You can reuse a lot of the JavaScript, and you can hopefully leverage some of the CSS and then customize it further. We actually just showed that in the previous talk that I was involved with earlier on today, just doing exactly that, having very different sort of user experiences, but the same markup and most of the same JavaScript. So this is something that the web's always had, because the web evolved from a situation where it wasn't tied to any one particular device or operating system. The web spread like wildfire and continues to spread today because it does run on this huge variety of different platforms and operating systems. Graceful degradation is another aspect of that, dealing with different types of device and different levels of support. So we talk about all these latest and greatest HTML5 features you've seen, like in the keynote today. They're not all there in all of the browsers, but they don't, the app just doesn't just go and explode if you're relying on something. If you're doing it right and doing it the way web developers have always learned to do it, you can fall back, and the web actually supports that intrinsically. So you've got this capability to say the canvas tag, okay, I don't have canvas, then I'll just fall back nicely. That's the content that will be shown instead of the canvas tag. If the attribute is not supported, because HTML5 is always adding new attributes to do extra things, like in this case to let you select multiple files. So in this case, that's not supported, fine. That will just get ignored. The app, there won't be an error, it will just get ignored, and you can just choose a single file instead. The font's not supported in this case, so we can actually choose the best possible font we would want. HTML5 lets us be very flexible with our fonts. We can actually, again, we can fall back to a font that does. So this is all in the whole spirit of the way the web works. Cascading style sheets is another aspect of this. So you can actually have one style sheet, and then that gets overridden by other style sheets. So you can say, well, we've got our desktop app. You can just publish a normal app for the web first, see if it takes off, see if it's interesting to people. People can start using it on the mobile already, and then a couple of years later, you decide, well, now we can start to customize a bit more for the mobile and have those rules override the previous rules. And then you can go even further than that. You can say, well, we specifically care about Android, or we specifically care about the Motorola Zoom or whatever. You can go as far as you want and actually customize as much detail, but you don't always have to. You can start from a basic point, get your app up and running, and see if people like it, and then tune it from there. The web's always had an idea about fluid layouts as well. So just by the nature of the way the rendering works, things tend to stretch in a reasonable way, and even more so, people have got well-established techniques now for doing these kinds of fluid designs to deal with all sorts of different screen resolutions. We've got sort of like the idea of one cloud. This is a very big idea in our industry. And now what I'm saying to you is with HTML5, you've got the ability to scale horizontally very quickly because you're reusing a lot of the logic. You're using the same technologies when you're jumping onto these different types of devices. So you might actually still be customizing a bit, but you can do that a lot quicker. So that's the sort of view from like HTML5 as a platform. On the mobiles, HTML5 as a platform, as far as the functionality goes, it's starting to get these technologies that will rival the native technologies. So we've got user interfaces, like you see a lot of great canvas things like Angry Birds and so on. But there's also things beneath the surface as well, the networking and offline type capabilities too that we need. And I'll show you some demos of this in a moment, but first I'll go through some code examples just to show you the kind of APIs that will support these sorts of things we've always had in the mobile browsers. So we've got, for instance, geolocation. We can actually, these are the kinds of things that are actually, in many cases, inspired by mobiles, but they've come back into the web, so they can be used on mobile web apps as well as on the desktop and elsewhere. Very straightforward API for doing geolocation, and as with all of these sorts of APIs, it's potentially sensitive, so just like you would get on an Android app, you know that you'll actually get asked if you'll give it permission. The web has that concept now too. You can do multi-touch, so we do now have touch events, and specifically we have the ability to do multi-touch as part of the web, the standard ways of handling events as well. We get an array, you can see there when there's a touch event, you get an array of all the touch objects. We can do device orientation, so that's now part of the standard too, works on Chrome on the desktop and some tablets as well, starting to get there. And we've got standards for speech recognition. Apologies, that's a little small, so that's input x WebKit speech that works on Chrome to do speech recognition, and there are device APIs as well to actually just capture different types of media. And you can see that they're actually building on the existing standard. So it's just a file input, but if you give it this extra attribute of what it accepts, the devices will be smart enough to actually switch into that form. And on the output side of things, we can do markup and styling with semantic tags. So we've actually got these kind of much richer things, much richer ways to explain the content on our page. And this is really useful, right? This means you create your web app like this, you've already got your content, you've handled your SEO, you've got your almost like a kind of API built in because you've got this content sitting there openly on the internet. You don't have to, you can close it off if you want, but the web tends to be open by default and lets you get that kind of sharing experience just by structuring your apps like this. And then you can style it really nicely too. So CSS3 gives you all these ways of decorating that content and getting the best of both worlds. You've got Canvas, so if you're doing even richer graphics, Canvas, you've seen 3D Canvas or WebGL today as well. We can do these kinds of graphics more and more inside the various mobile devices. And multimedia as well is possible too, so we can actually do video and audio now as part of HTML5. This is an example of a native app that's on the iPad, just one more. They're using Vimeo's HTML5 video API to actually show videos inside this native app. I'm going to switch gears now. I'll show you a demo of some of these things I'm talking about here. Let's see. Get this guy on.
One.
Whoa. Which one are we on? 2, 4?
2.
2, gotcha. So this is geolocation. So just to prove this works, let's see how it goes. So it's asking me if I want to share my location. So we've got the coordinates showing up, and it's doing a bit of mashing up to actually show the weather and so on. Multi-touch test. So this is inside a browser. So you can see here, it'll actually detect all 10. I'm going to leave that one. That's the more fun one. So this is 3D transformations with CSS3. So this is decorate. We can actually decorate content this way. And this is bit.ly. So if I jump here, it's generating those graphs in real time inside the browser. But the most fun one is the one I've actually written for this talk. So you can see I'm taking a few photos around the place here inside the browser. So let's see if I can get this working. I'm upside down here. There we go. And this app's running offline as well. So, whoops. Go back. Yeah, so this app is actually running offline, so it's just stored. So now I'm in the DOM. So I'll go put you guys in the DOM as well, in local storage. Wait for it. I'm going to switch the camera around. So say hi. Sorry, I can only get the middle row here, the middle aisle, but go on. Say hi, IO. Whoops, wrong way. All right. And it's kind of jumping around whichever way I go. But I'll leave the, okay. So now you guys are in local storage as well. So I can actually, if I reload this, well, actually, I don't know. I'll reload it just to show that that's actually coming. Well, anyway, I won't go offline, but it will work. You can try this later on. If you try that URL, html5photos.appspot.com, you can see that works. You can try it on the tablets you got yesterday, because I've tested it. It works on there. It's just a basic proof of concept. And it also works on the desktop, where you can actually use it as a way of keeping photos offline just by using the file input and pulling photos from your hard drive. Let me jump back. But it's more than just the user interface side of things. It's also about doing these sorts of things in the sort of back-end functionality as well. So things like networking. Where the web really took off was a few years ago when we had this concept of AJAX. It was the recognition that suddenly the user could be working in the browser, and at the same time you could have all this communication going on back to the server that sent down that application. For security reasons, you couldn't actually go to other domains. A few hacks have come about to make that possible, but now we've actually got that built into the standards as well. So we can start to do really sophisticated mashups by using cross-origin resource sharing and going across to other domains. And we also have WebSocket and some other technologies as well to do proper real-time streaming. So it's not just the case of the browser making a request, we can also do live communication channel back and forth. And you can see Rumpet Roll will work already on some mobile devices. Offline, so this app here, it does work offline. You can try it for yourselves. Just visit it once and then take it offline and try it and then hit reload. You'll see it work. It's using the application cache. Very straightforward technology where essentially you just need to list your assets. And some of you might have seen the Chrome Web Store talk yesterday where people like the New York Times were mentioning that it's not just about being offline, it's also a massive performance improvement. So the same sort of situation as a native app where you have your content, you have your app as well as your content that are all stored inside the device. You can do the same thing with the web now. You don't have to make it like every time you go and start this app, it's going to load the whole thing. And offline storage is another aspect of this as well. So you can actually have, storing not just the application logic, but also the actual content. So that's showing you that HTML5 is here on the mobiles, and it's also a very capable technology. But it's more than that. It's also just some intrinsic things about the way the web works that I think are quite compelling for developers. It is based on standards. So while it takes a little bit longer for those standards to evolve, and it's kind of a messy standards process, ultimately what you end up with is several implementations of these standards. And these implementations, like you've seen with these massive performance increases we've seen from the likes of Chrome, that it causes a lot of competition between the different browsers to keep innovating and also to keep coming up with new standards. Like I've tried to show you here today, it's okay for a browser to go ahead and come up with a new feature that might not yet be on the other browsers because you have ways to degrade, and there is a standards process for the other browsers to adopt those standards too. And it's also the fact that you're on the web. You've got that content sitting on the web, so you've already got a lot of your search problem already solved and the ability of making it accessible as well to things like screen readers. The actual technology of the web is becoming more and more popular. It's very much already for a few years now seems to be what people like to think of as a lingua franca, a language that just by its privileged place in the browser, everyone has to know some JavaScript and some HTML5. There are now huge communities of web developers who consider it their first and favorite language. There are other people who still prefer other languages, but they still know a lot of these technologies. And we even have server-side technologies like Node now that let you write the entire app on the server and the browser in the same set of core technologies in the same programming language. So you can see why people like this. This is a quote from The Onion here, but it is actually serious, I'm told. That's basically, they're making the point that they've got the iPad app and they're doing it in HTML5 because they already know it. They already have a website. They have to have a website. They have to have things running as apps on the web. So they're just leveraging all of that existing skill and resources. And finally, HTML5 is a very well-supported technology now. It's been around for a long time, and you've got some great libraries that have evolved since the whole AJAX revolution. Libraries like jQuery that you hear a lot about. There's great debugging tools. There's Chrome dev tools, for instance, that make life a lot easier for developers. And there's a whole community as well. So there's a lot of, it's very easy to get on board with HTML5. You just open up a text editor and write something and run it in your browser. Everyone can do that. And just to actually skill up from there is a lot easier than it used to be. And there's just this huge community of blogs and tutorials and everything around it. So I think I will leave it there and leave it for Reto.
All right. Thanks very much, Mike.
Thank you.
He'll be back later, but I'm sure he appreciates
it
the
anyway,
applause.
yeah.
So he's made a good point, right? There's some really interesting stuff there, some really compelling reasons why building applications for mobile phones on the web is a really good idea. What really appeals to me is this idea that you have this cross-functional approach, that you have an app you write once and it works across all the smartphones, or at least all the modern smartphones where you want your apps to be used. So why would you risk losing that? Why build an app which is only one platform? Well, there's 100 million reasons in one instance why you might want to. There's a lot of Android apps out there, and we want to try and create something that's optimized for those users. Before I get into the details, I want to talk a little bit about the terminology we're using. So we've thrown the word native around quite a lot already. If you're Android developers, often when we're talking about native apps, we talk about something slightly different from what we might be considering. So for today, when we're talking about native, it's really anything built specifically for the Android platform. Because there's actually a few ways that you can do this. It's not just about writing things for the Java virtual machine. That is the most common way of doing it. So most of you guys, if you're Android developers, are probably writing things using Java syntax, which is going to be running on the Dalvik virtual machine. And that's certainly the majority of apps. But we also have a number of different alternatives. And one of those is actually what we call native development. So that's using the native development kit. You can actually build apps using C or C++. And that takes you one level further down. So rather than running on top of the virtual machine, you're actually running much closer to the metal underneath that. We also launched something called RenderScript, which is a way that you can write even faster graphics code. And that's how things like the Google Books, the page turn animation works, the YouTube dynamic gallery, all of that stuff is written in RenderScript, which is actually the coding language there is a variation of C, C99. And we also have the ability, using the Android scripting layer, to be able to write things in scripting languages, things like Python, Perl, those sorts of languages. You can actually build apps using those languages as well, though they'll have to run on top of an additional interpreter. So when I say, I want you to build native apps, I can mean any of these things. I don't really mind how you do it, but I do want you to focus on Android specifically and on the hardware layer. So what are the advantages? Why are we wanting to build native apps? And it's really because it gives you a much richer experience. You're able to build things which have much broader access to the underlying hardware. And it's not just that. You also have a closer integration to the system features. You have this ability to create apps which are optimized specifically for the hardware that they're running on, specifically for the systems that they're running on, and with the other software that's going to be running on those systems. So it gives you the ability to write something that's not just an app which is running on a screen, which could be running on any hardware. It lets you create something which is optimized for things beyond the screen size, but the hardware which it's running on as well. So why? Again, why develop? So for me, it's all about power. It's the ability to write something that's faster, smoother, more efficient. And that was a key element in one of the presentations I gave yesterday around how to build great mobile apps for Android. And it's all about trying to make things as smooth, as fast, and efficient as possible. The thing about mobiles is that they are resource-constrained devices. They're getting increasingly powerful. They're great with tablets, dual core, all of these good things. But it is fundamentally still a resource-constrained device. Manufacturers are going to try and make the devices smaller, and they're going to try and make the batteries last longer. And that's going to come as a priority above making them run faster, which means that every ounce of efficiency that you can pull out of the device to make your app work better is going to be valuable. And so when it comes to the idea of building something natively or building something on the web, you're basically asking the question, can you afford to lose the additional efficiency and power requirements by sticking another layer in between your app and the device that it's running on? The thing is, all of that is true, and even if the functionality of HTML5 was exactly the same, as native, then that's already a reason to think about building native instead. But there's a whole bunch of additional functionality which you can take advantage of, which is why I really think if you can't improve on a web app using some of the Android SDK APIs, then you're probably just not trying hard enough. Right, so that's a laugh from the Android part of the crowd. I thank you for that. But no, seriously, there are so many things which you can do now using the native APIs. And it's really all about innovation. And so the great thing about the web is that it's standards-based, right? The whole advantage is that you write it once, and you can optimize it for a number of platforms, but fundamentally, you can write it once and run it all across the web. And that's fantastic. The way that works is because it's all standards-based. And the problem with standards is that they necessarily have to trail innovation. You can try to set a standard before a piece of hardware exists. It doesn't generally work really well. A much better approach is to find out what's happening, what are people innovating with, what are people using, and then create standards to be able to make that more broadly available. That's fantastic. But what we're seeing is a lot of the most popular apps, a lot of the most successful apps, are right at the leading edge of that innovation trail. And that goes both in terms of hardware and software. If you're looking at hardware itself, the rate at which mobile hardware innovation has been traveling over the last few years is phenomenal. If you compare that to netbooks, notebooks, any sort of desktop computer, it's been pretty much the same thing for decades, right? Once the joystick fell out of favor, it was screen, keyboard, mouse, and then different ways to connect peripherals. But fundamentally, it was the same user experience. With mobiles, that's completely changed. It's only a few years ago when the first iPhone came out that we started to have multi-touch on mobile devices, accelerometers for being able to do game control. And then Android comes on the scene. We get access to the video APIs, compass, background apps start to appear. And then every year that's improved. So next was Bluetooth, multiple screen sizes. Then last year we had gyroscopes, front-facing cameras, and these things have really revolutionized a lot of apps. Think about some of the apps which you use, which are only possible because of these innovations. And the leaders were the ones which were able to get in there and take advantage of those new APIs as soon as they were released, without having to wait for everyone else to be able to do it as well. This year we've seen barometers on the Motorola Zoom. I haven't seen anyone use that very constructively yet, but I am looking forward to it. NFC, huge. It's staggering technology which is starting to roll out. You can wait until every phone has NFC, or you can start building apps which take advantage of it now and be a market leader for when everyone does have NFC. Tablets, USB accessories, Android at home, all of this great stuff which we've seen launched over the last couple of days. All of that is an opportunity for you to create something new, something innovative, to be at the real forefront of that market. What we're seeing these days is that device manufacturers, they're using hardware as a way to differentiate. And that's one of the advantages of Android. They all have the same software platform, so they need to build cleverer hardware. They need to come up with new features. So this is what we've seen over the last 3 or 4 years. Imagine what we're going to see in the future. I think it's going to continue to innovate and continue to grow. We've seen exactly the same thing on the software side, right? So along with that hardware, we've also seen great innovations in mobile APIs. And these are some examples of some apps which have really taken advantage of this to become market leaders, whether it's Google Maps using location-based services, which we all totally take for granted now, right? We all know that our phones know where we are. This is just assumed that every mobile device can do this, but it's actually a relatively recent thing. Shazam using audio input, Goggles using video input to do video recognition, image recognition, Angry Birds, touch screens. The way games are played has been totally revolutionized by smartphones with accelerometer input, compasses, video, all of these sorts of things. So really what I'm saying is leverage the hardware that's available, particularly when new platforms are coming out. So we've all been using smartphones for a long time. It's been, 3 years, so it's passé now. What we're looking at now is tablets, and all of you guys have tablets, so there's no excuse for not getting into tablet development. And it's more, right? There's Google TV, that's around the corner as well. I mean, literally around the corner. It's actually out. And we're seeing Android really populate a much broader spectrum of devices, whether it's cars or whatever else. We're seeing this single platform as a place where you can really take advantage of the hardware. We're going to build the APIs to make it easier for you to use. And that's what the Android accessories development kit is all about as well. It's trying to give you as developers access to be able to program for more things. I mean, this is really revolutionary. We're now living through a time when we're making it possible to write code which runs specifically on different hardware platforms. It wasn't that long ago that it was very difficult to actually get a piece of software you wrote to run on an actual phone that someone will go out and buy. And now that's something that you can do right now. If you're bored during one of the presentations, you can write an app, launch it on market, and it'll be there. And what we're seeing is that this is now propagating across a whole variety of hardware. So one of the key messages I want to take away from you, or give you guys to take away from this, is think about the actual hardware that your software is running on. If you're building something for Google TV, you should think about the APIs that are specific to that. How can you integrate TV guide information or whatever else makes sense for that hardware? And it's the same with tablets, it's the same with smartphones. And that's what native gives you, is the ability to start using that hardware as soon as it's available rather than having to wait until it becomes ubiquitous. And so this is some of the stuff which is available right now for native development. So obviously you can develop for smartphones, tablets, and TVs. Audio input is ubiquitous. Video input from front or rear-facing cameras is all there today. 10-finger multi-touch input, which I will grant you, Mike, is now also available on many mobile platforms for web-based development as well. And things like a generic sensor API, so that as new hardware sensors get added to pieces of hardware, you're able to integrate that into your applications really easily. And that's where we're seeing things like orientation, accelerometers, barometers, a variety of new hardware. I think there's going to be a lot of growth in that area as well. One of the key things as well, which isn't as common, is this ability to get right to the low level. So having access to the telephony, Bluetooth, SIP stacks, USB, all of these things make it possible for you to create apps which fundamentally interact with the hardware. And in fact, it goes that one step further, because your native apps aren't just something which sits in a sandbox, in an application sandbox, or within the browser. They become part of the ecosystem on the device. So that means that you can do things. You can actually work with the system. You can listen for system events. So if you want to build an app which is going to listen for incoming calls, do a reverse number lookup, and display who the caller is, you can do that. You can register an intent to listen for incoming calls. You can do the same thing with other apps. So if you want to have an app where you want to display a location, you're able to make a call, again, using the intent framework to say, have something display this on a map. And if Google Maps is installed, it'll do that for you. You can do the same thing in reverse. So if you have an app that can book hotels, and you say, well, look, any app which wants to be able to do this, just send me the name of the hotel and I will book it for you. So it's a way that you can have all of these apps interacting with each other, as well as interacting with the citizen, with the system itself, because they are all first-class citizens, which means you can replace any of the apps on the device as well. If you think you can build a better home screen, build it, launch it, put it in market, and people will be able to use it. Same with dialers, same with contact managers, anything which is on the phone, you're able to create an alternative for. Another thing which I really like about native apps is that they can be truly background. And obviously, the most common use case for this is a concurrent app, like have a music player in the background and you can continue browsing at the same time. But it's really more than that. Native apps let you be able to have much fresher data by being able to continue to update in the background, even if the app isn't running. So you don't have the associated battery drain of having something which constantly runs. You can set an alarm and say, when connectivity returns, do this. Or if an incoming call comes in, that's when I want my app to be started up and to be active. And for all other times, it can be completely stopped. It can be not running at all. You can also do things like a server-side push. So cloud-to-device messaging lets you transmit a message from a server to your app to say, you have new information. So start up and download something, or notify the user of something. You can actually do the same thing on the device. So again, you can have these recurring background alarms. So your app can be completely off. In fact, the device can be on standby. And you can say, look, every hour, I want you to wake up, pull down the latest news headlines or tweets or whatever it is you want. And then as soon as the app gets launched, it's able to have that fresh, up-to-date data. And the advantage here is twofold. Not only do you get fresher data without having to do an explicit reset, but you also save on battery life because your app doesn't need to be constantly running in the background in order to get those updates. Full offline support. I mean, this is something which, again, is coming to HTML, but it's something which is really rich on the native platform. So not only can you have your app data cached, you can actually download the entire contents, store them on the device, and have them available for things like search. I use Gmail every morning on my way into work. I triage my email. Constructive use of my time. The thing is, I commute to work via the London Underground, which means I have no internet connection for most of that journey. But it doesn't matter. I open up Gmail, I read all of my messages, archive, reply to, put it in my pocket, and then as I walk to the office, it gets a 3G connection, and everything is synced. By the time I sit at my desk, everything is up to date. And it's that rich offline support without ever really needing to be online at all, which creates a really great user experience. One of the other things, and this is something which I really like about Android specifically, is the fact that your apps become more than just an icon in the launcher. You can create home screen widgets, live wallpapers. You can have notifications which get triggered to tell you of things like incoming email or instant messages. And because all apps are created equal on the platform, you can do anything which any of the native apps can do. And so this is a really great way of being able to make your content much more engaging. So someone doesn't have to remember to navigate to your site or look up a bookmark or even start your app in the launcher. By having widgets, notifications, you're able to pull more traffic, more engagement, more users into your app. Because that's ultimately what you want, is for people to use your app more. Downloading it is really only the first step. So this is a little summary of all of the things that you can do using native APIs across all of the Android devices. And there are additional things which are limited to some of the newer versions, but this is pretty fundamentally everything that is there. So I'm going to hand back over to Mike.
Okay, so I just wanted to really summarize our two arguments, and then we'll shift gears a little bit towards making this practical. So to sum up, really what I'm saying here is that HTML5 is a technology that's here now on the mobile devices, as well as many other types of hardware. It's capable platform as well, so it's got these advanced UI capabilities I've shown you and beyond that. And it's an open technology. It's something that many people in your organizations probably already know, and you have to have web apps anyway. People will use the browser. So it's got all those benefits. On the other side of things, Reto has pointed out with native apps, they tend to be more integrated with the deeper hardware integration that tends to stay a step ahead, as well as the fact that you've got the user experience that's like built into that native look and feel for each of the platforms. So really the next point really is just to say, like, what can we actually do about these things?
How many of you guys were hoping that we would give you one answer so you would be able to come out knowing? Yeah, a few of you? It's really not that straightforward, right? It's not as easy as which should I do. If it was that easy, then Google would just do one. But we don't. We do both. And fundamentally, that's the answer, right? You can't just be focusing on one thing. It's pretty clear at this point that the web is the future, so you cannot ignore this as a platform. And if you want real reach, then building a mobile app, which is web-based, is kind of a no-brainer. You can build one app and it's going to run all across all of these devices. And for a lot of content, that's going to make perfect sense. You should be building something which everyone can use. But at the same time, there's all these native APIs, all of these native advantages which can let you build something really great. So fundamentally, I guess what we're saying is maybe build a web app for everyone. And if you've already got a website, then it kind of should already be a mobile optimized website as well. That's increasingly how people are trying to access web content, is on mobile browsers. So that's kind of a gimme. Beyond that, you want to then create an optimized version using those native APIs to build something better. One of the ways you can do this while leveraging the work you've already done is by using web views. Most of the smartphone platforms have something equivalent to a web view, but I'm going to talk about Android specifically. But this is a way that you can embed web content into your native applications. It's kind of an obvious thing to do here. If you've got content which has already been formatted, looks beautiful, you've got your UX people building stuff in HTML, why not use that to display the content within your applications? What you do then is that becomes the mainstay of your app, and then everything else becomes Chrome. So you then, all of the action bars, all of the interaction with accelerometers, with the native hardware, you can do all of that stuff, but then just display the content specifically using a web view. And in fact, if you've been using the Google I/O app throughout the conference, you've already been using an app which does exactly this. So all of the maps are actually done not using a map view, but by using a web view, which is using the Google Maps API. And you can see we've got the real-time stream of tweets, I think. And that also is going to be just a web view, which has a particular amount of content put into it. Everything else is purely native. So all of the action bar stuff, all of the things which are optimized for tablets or smartphones is all done natively. But we have this ability to just wrap the content for specific parts of the app using a web view.
And I just want to finish off with a few tips on just HTML5 and JavaScript in general when you're dealing with the mobile devices and going across the various platforms. Firstly, there are libraries available. I already mentioned that you've got these libraries that are now very powerful and very widely used, like jQuery, that are just used for general web applications. Those things also work. They work quite nicely in most cases on the mobile devices as well. And at the same time, there are more and more mobile-specific HTML5 frameworks and libraries that you can hook into. So there are things like, we've got Semantic Tags here. This is an example of an app they've created that works right across the board, showing a conference schedule. Sprout Core, this is a touch app, but you can see the same kind of app running in the Chrome Web Store as well. So it's that experience or that philosophy of writing the same app. And in the case of the mobile or the tablets, you can swipe and just go across. Otherwise, you use the mouse on the desktop. It's an NPR app, actually. And jQuery Mobile is kind of a new kid on the block here and already very popular because it's based, or it's the similar sort of concept as jQuery with the same team. It's actually very sort of more of a microkernel approach, and it's got the ability to theme so you can cover the different devices, and a very permissive license as well, being MIT-based. Think about progressive enhancement, the idea that you have your raw, basic web site, a traditional website, just some markup. Again, something we showed in the previous session on mobile development for the web is that this actually does work. We showed this working in your basic browsers like Opera Mini, and many people do actually still access the web from very traditional devices, that have very basic web capabilities on the mobiles. And if you do your app right, you can actually get it working for those as well. And then you go ahead and you enhance it. So actually, in this case, we're basically hijacking these links to actually say, if we do have JavaScript here, we're going to go further, and we're going to actually not go ahead and click to reload the page. Instead, we're going to do something dynamic. We can do fallback. So I already showed you can do fallback with something like Canvas or any other tag. If it doesn't exist, the browser or the HTML5 runtime, it will still process it. And we can do that sort of thing with video too, and we can fall back from one format to another format to Flash to just downloading. We can do feature detection, very important thing nowadays, based on the premise that you can't try to detect every sort of different device. It's just not practical. And even if you could, you wouldn't want to create separate apps for all these different devices. So rather than having this whole combinatorial explosion of apps you have to deal with, just put a little bit of intelligence into your app to make some decisions as the app is actually running about what to do, and then perhaps download some extra content or some extra type of application logic depending on what are the capabilities of the current device. Like I said before, HTML5 is not perfect, it's not a magic bullet. You still have to do some difference of logic and so on to reach all these different devices, but the benefit you get is a vast amount of reuse. There's library support for this sort of thing too. So we've got a library called Moderniser that's becoming extremely popular, which actually does the detection for you. On the previous slide, I showed the kind of low-level detection you can do, sort of doing things like creating something and seeing if it actually was created, or setting an attribute and reading it back to see if the browser actually recognized it. You don't really have to do those low-level things anymore for feature detection because there are libraries like Moderniser that do it for you. There's also a slightly higher level layer on Moderniser that will actually, it doesn't have to be Moderniser, but it's basically around those kind of use cases for people who are using Moderniser, called Yep Nope, and basically says, if you've got this feature, we're going to download an extra layer of JavaScript and CSS. If not, we'll use something else. Polyfills is the idea that you don't necessarily have to fall back. I've already talked about graceful degradation, But what if you could actually just fake it, right? And actually say, we don't have this particular feature. We might not have SVG in a browser like IE6, for instance. So we'll just fake it. We'll fake it with something else. So in this case, we can say there's a library called CamG, which will actually fake SVG using Canvas for things that have Canvas but not SVG. Storage, so I've already shown you a little bit about local storage to make your apps work offline. Really old browsers don't have even the basic local storage support. So for those browsers, you can resort to everyone's friend, the old cookie, and store a very minimal amount of data, but you can still do something useful with that. And likewise, geolocation and so on. And the point about these is you can use them yourself, so you can talk to that more modern API, and eventually when those devices and browsers become deprecated, you can just switch off any kind of checking. But also for third-party libraries, these are really powerful because the third-party libraries might be taking advantage of those newer features, and you can sort of jump in. JavaScript's a very dynamic language that lets you do these things like what's called monkey patching or hijacking. So you can sort of intercept things and say, actually, no, the object you're talking to, do this instead, use this object. And finally, I wanted to share with you, I spoke to Roman, who actually created the I/O app that you've seen. Just the sort of techniques that you can use, and he's using there, to actually communicate back and forth between the native components of Android and the HTML5 components. So if you are creating one of those sorts of hybrid apps that Reto was advocating a moment ago, you can go in both directions with Android. You can basically have the native part talk to the JavaScript part, basically making calls using that load URL command. So if you've got a web view, instead of actually load URL opening up a new website as you'd expect, you can just pass it JavaScript commands the same way some of you might know you can write those kinds of JavaScript commands on the actual browser, like the way bookmarklets work. And in the opposite direction, HTML5 can actually talk to the native components using this pretty cool method that's add JavaScript interface. So it lets you kind of send in a native component into the JavaScript app, and you basically provide an interface for that. That gives you full communication between the two, unless you write one of those hybrid sort of apps. I think that's about all. We've got some resources there to help you with, and I think that's it. I think we can take questions now, yeah? Great, thank you.
One of the technologies that you didn't talk about, and they also have a sort of a similar message, is Adobe Flex and Air, because that's available on Android, on BlackBerry Playbook, and also there's a way to get it onto iOS. What would you suggest the strategy, like Adobe Air versus HTML5 versus native?
Yeah, I think it's an interesting sort of third situation with the Flash and Air and so on. I guess the way I see Flash, people always ask me about Flash, I think it's been a good technology on the web for actually going a step ahead, like the same sort of way Rito's talked about native technologies going a step ahead. I think Flash has always done that. It's now going to be a challenge to see if it can keep on going in that direction. I think the web has some obvious advantages. The fact that people do just have to have normal websites. It's an open technology without any one particular vendor controlling its destiny, if you like. So I think that's where the challenge for that whole set of technologies is, like, to keep staying ahead of the game. So you could have those kind of native technologies, but actually go across the different devices.
Yeah, I think that's the big challenge for the Adobe stuff, or really anything other than sort of web or native, which are the two extremes, is not getting stuck with the negatives of both worlds. You know, it doesn't work on everything, and it doesn't have the full range of native support. So I think that's where the challenge is going to be.
And there's also, in some respects, there's been better tooling traditionally for Flash as well. So that's where the advantage over the web has been, but now there's starting to be a lot more tools for, and actually not just those sort of libraries I've talked about, but people are just starting to write sort of animation toolkits and so on as well.
Thank you.
Yeah, if you're developing one of these hybrid apps, you've talked about the JavaScript bridging. Is there also a way where you can manipulate or take over the cache or the loading of sub-resources within the web view? You can do that on iPhone. Is there an analogous way to do that on Android?
I'm not sure. It's not an area which I've looked at too closely. I'm believe that you have pretty much full control over what happens within the web view, but don't take my word for it. They think they're still doing Android office hours upstairs. It's a good question to ask someone there from the browser team.
Is there a particular person you'd recommend?
I'm not sure who's around, so
Okay.
no.
Thanks.
No problem.
The tabbed view you had that included the HTML5 photos, was there a
Yes.
URL for that whole thing? It was public?
I haven't got a URL for the whole thing. I can put it on Twitter, I guess, afterwards, after this talk on my Twitter.
Okay, but there was no helper app to get that photo. It was just looking for a
the-
file in that
Sorry,
terminal.
the URL specifically for the photo app.
Well, that was
is-
HTML5photos.appspot. And my battery died, excuse me. But that thing will trigger the camera without a helper app?
To trigger the camera is, well, that's just on the slide. So I've got there's no URL. I mean, it's just an input
Right,
type
but you hit
equals
the
file.
button, you got a photo.
Yeah, that's just a special kind of input type. So
Okay.
I've done input type equals file with a special accept. You'll see that on the slides when they come out. It's just a single line, basically. And then I'm using reader, so you can actually, there's also file APIs, basically. This is on HTML5 Rocks, actually, how you can actually manipulate
Oh, it is all
that.
there, okay.
So, yeah, once you've got the file, you use file input with that accept to actually put the file in that element, and you can then read it using file reader API.
Okay, thank you.
Okay.
Hi. First of all, awesome talk. I actually was going to ask a question based on the fact that I'm sure you actually get more of this input than I do. So I didn't see this on your list, but do you think security and transparency is actually a factor? So what I mean is, like, when I look at an HTML5 app, I can pretty much kind of look at the HTML source, I can figure out the JavaScript, I can figure out what's happening behind the scenes, and I can use user scripts, I can use extensions, I can kind of manipulate stuff in there. Native apps don't let you do that, and even back in the J2ME days, you wanted to kind of do things to hide stuff from your competitors. So are you seeing developers see that as one of the reasons for picking one over the other? Just curious.
Well, from the native side, it's not something that I've come across. I mean, certainly there's certain industries, particularly around banking, but to be honest, they are very comfortable with the way things work on the web now. The advantage of the web, it's been around for a long time, and there's some really great security things built into it, and there's a certain level of comfort. So as far as obscurity goes, I haven't seen anyone develop a native app in order to make their code more obscure. But I would imagine that from a user point of view, I guess turning that around, so a lot of the banks are more comfortable with a web app because they understand the security model. They know that their users understand the security model. So for users, yes. Developers, probably less so.
There's on the web side of things, it's a little bit different. We've seen this with the Chrome Web Store, for instance. People tend to be concerned about two things. One is the application, so people actually potentially stealing their application because it's open. And the other is the content, right? So actually digital rights management and people actually being able to lift movies and music that they're actually serving. There's a couple of things to say about that. Firstly, there was a really good comment yesterday in the Web Store panel by the chap from New York Times who just made a point that people who would tend to be really good, the people that you have to worry about as a competitor, don't tend to be the kind of people who would actually consider doing that anyway. But beyond that, I think the way I like to see it is that these technologies have sort of a standard default that you can vary. So the web tends to be open by default, but if you want, you can apply obfuscation and so on to close it off. And likewise, native technologies tend to be closed by default. They're sort of binary, but if you want, you can always put the source up on on a repository or something. So it's kind of, it works both ways, and it's really down to the developers to open and close it.
Yeah.
Right, so I have 2 or 3 comments. The first one is, you talked about, I guess, on the side, about, sorry, the fact that, one of the advantages of native is less stress on the power, and you didn't address this on your HTML5. I think that's a huge important thing because power is so critical. The other thing is, and I guess I'll just summarize it by this, is why not think of just like GWT instead, which is write it for Android and then compile it for HTML5. And I'm sure there's going to be cases where you're taking advantage of the hardware and that compilation wouldn't work, but at least a lot of the skunk work that you would do in HTML5 can be done for you by the compiler.
So I don't understand how you can write it in Android and then compile to HTML.
You write it in Java. Like right now, if you write it in GWT, you can compile it and it works on
using GWT.
Yeah, so now you do an Android version of that.
And that's the Angry Bird strategy that's working in GWT, so there is a possibility.
Yeah, absolutely. I think part of, if I understand your question or comment correctly, I think one of the risks if you're using something like GWT, it's the same sort of issue that you may have with something like the Adobe solutions, which is if you build something which is generic, then you may as well build it using web technologies. And certainly, GWT is a great way to build web technologies, but I don't think we would get to a scenario where we would want that to output Android code.
No, I'm saying the other way around.
The other way around.
No, you write code
Android code.
just in Android, and then you tweak the compiler, the Java compiler, so that it generates HTML5.
Okay, so again,
Because you have the code already. I mean,
Sure.
It can work. It's another strategy depending on where you come from. I actually had a partner who did this, who actually, with the Chrome Web Store, they already had an Android app, and they were able to really quickly, I actually was really surprised about how quickly they could use GWT to actually turn it into a very capable web app. So it is definitely a strategy if you've already got the code base or the understanding about how to do that, yeah.
what about the power thing for
Yeah, it's a
HTML5?
good question actually, because Reto was talking about this. Chrome now actually has the concept of background apps, and it is just Chrome at this stage, but a lot of the things that Chrome introduces are intended to eventually become standards. And it does actually have this concept that you'll see New York Times is one company. There's quite a few that are starting to use it. So it can actually run in the background. And actually, it kind of goes against your point too, because it's actually using more battery while it's in the background. So yeah, I mean, it's I don't know, why would you say that it's using more battery?
Well, I mean, I know iOS quite well, and I can tell you that in iOS you get events, and you have to put your app to sleep.
Right.
And I think in Android you have similar events, so I'm exploring them now. So you essentially are participating as part of the platform, which is trying as hard as it can to maximize battery life.
In contrast to keeping a web app running the whole time. And that's where the background apps do help, because with Chrome you've got the ability to launch these background windows, which are invisible windows that can just wake up, or just run a timer and just wake up every hour or whatever and just do a poll. So it's just starting very early to get there as far as the standards go.
I think what we're going to find is, so one of the advantages behind Android is that it's ultra optimized for mobile, like least power, most efficient, etc. The reality is that the web browsers which are running on these platforms are going to have exactly those same things. So Chrome originally was not designed as a mobile browser, and so that wasn't the focus. The focus was around all of these other cool things, which everyone uses and wants to be able to do in the most efficient way. As we see things now, more developers creating browsers for these platforms, that's going to have to be their focus as well. And so there'll be solutions to things like the background stuff, but also just more efficiency, generally speaking.
So my question's around, if you do the HTML5 apps or take a Chrome web app out of the web store, can you put it in the marketplace too, Android marketplace?
You can using some technology. So there's ways of actually compiling it down with some frameworks, but there's also ways of actually doing it yourself, like what Reto was suggesting, the kind of thing that the IO...
So a hybrid app, you can put it in marketplace.
Yeah,
but
there are also frameworks, and there are ways of actually not just taking the kind of approach we've done here, but actually like compiling it. So there are starting to be some technologies that people are doing to actually take like something that talks to Canvas on the desktop, and then it will go to OpenGL inside Android.
And then that would qualify it to be in marketplace then too. Okay.
But yeah, well, you still have to wrap it as a native app, but yes.
My question is related to this one. The way the Chrome Web Store connects apps to users, which are pure web apps, doesn't it make sense to have a similar store that connects mobile web apps to the users, where people can discover mobile web apps in some kind of a store?
Yeah, that would make sense. I think the question of how you put Chrome apps designed for mobile and make them more discoverable on mobile devices, on Android devices.
And don't have to wrap it up just so that they can be discovered, so they can be the first-class citizens on their own, being mobile web apps.
So I'm not sure internally of what the plans are. Two separate teams, so I have no idea. Personally, my preference would be to see search become the way that you discover it, so that you have search which is much better at discovering both native Android APKs and web-based apps as well, rather than having sort of different markets or indeed any market. But I have no idea what the actual plans are.
All right, thanks.
Last question.
This is really more of a comment than anything else. I guess one thing is that, if you guys are building kind of a hybrid app in this case, you should probably remind people that the actual rendering engine is not the same as what they would have in a browser or whatnot. Like, for instance, what the gentleman said there about iOS, you know, the people are very surprised when they get a UI web view and it doesn't have like JIT compilation unlike mobile Safari or something like that. For the HTML5 portion of it, remember too that the network is the most expensive thing when dealing with mobile, less so than the power consumption, all that other stuff. So if you're dealing with lots of, you know, I know that Android 2.0 and 2.1 supports HTML5 web workers and 2.2 and 2.3 do not anymore. Thanks. If you're doing that, you're like, you know, pulling up a couple threads in the background and spinning off extra resources. That's very expensive. And then 3, your solution doesn't always work in certain situations. If it's a pure HTML5 web app, because say you're European and you use somebody like Vodafone or, you know, Orange or something like that that use things like content transformers actually at the network operator level, your app is just toast, and yours actually works. So.
Yeah, it's definitely there's definitely no easy solutions. And I guess that's an important takeaway, is that you really need to look at your market, look at the devices, and look at the technologies, and figure out something that works best for what you're trying to create.
Yeah, and like I guess what the gentleman was saying before about GWT, it was that it would be great to be able to take GWT itself, have it export out HTML5, does a little bit of the exploratory on the device, sends it back to the server, and actually optimizes for that device so that you wouldn't have to have that back and forth that you would with Moderniser or those other tricks that you introduced. So.
Absolutely.
Good
Cool.
points.
All right. Thanks very much, everyone.